Good morning, everyone. Thank you for joining. We are very excited to announce our guest speaker today, Bella Treyger. Bella is CYP Mission Critical Facilities lead principal for our Fire Protection and Life Safety Department. Bella has over 30 years of research and development and consulting experience in fire protection, life safety, and plumbing engineering. Her experience includes designing fire suppression systems at hundreds of large-scale data center facilities around the world. Bella served as president of Metro Chapter of the Society of Fire Protection Engineers. She has been a board of directors member since 2001. She also served on the advisory committee of the New York City Fire Department. Welcome, Bella.
Thank you.
Let's start with the first question, Bella. What are the data center market trends in fire protection and life safety?
Well, as you know, lately the markets have to be economically sound, so that dictates the trends in the fire protection as well as all other systems. So I would say that 80% of the data centers today are designed with sprinkler systems. Sprinkler systems being either wet systems, which is very rare, or pre-action sprinkler systems. And like I said, it's about 80% of the market is sprinkler systems protection with some sort of detection system that monitors the sprinkler system and works as an early warning for the data center management.
Now, when designing a data center, does it affect the type of industry that we get involved? Like, for example, designing an enterprise data center for a bank or financial institution, or designing a co-location or a hyperscale, or even government. How does that work?
Oh, it absolutely makes a huge difference. For example, when we're designing a data center for a financial enterprise or a government agency, the data centers tend to be of a higher tier classification requirements. So, for example, the financial institutions, most of them are designed with 3+. Same thing for the government, even higher, tier 3 or tier 4. The co-locations designed for a variety of tenancies. So the co-locations obviously are designed with the minimal costs involved. Therefore, you know, the owners of the co-locations, they do tend to protect with the minimal code requirement systems, or the local authorities having jurisdiction, which translates into sprinkler system with intelligent, addressable fire alarm system. When we talk in enterprise for the financial industry or government, it's going to be absolutely a double interlocked pre-action system. It will be charged with the nitrogen to prevent all sorts of corrosion. It will be it will have air aspiration detection as the monitor of the systems. And in addition to that, the most critical areas such as data center or most critical infrastructure locations within the data center will be protected by some sort of clean agent gaseous systems. The systems are usually designed in stages for those type of facilities, financial and government. So the first stage of defense obviously is a very, very good fire alarm system, which consists of aspiration detection. The second stage in protection will be a gaseous system that, if it discharges and leaves almost no residue, does not require a lot of cleanup and does not affect the works of the data center, the computer racks, and etc. And the last stage of protection is a sprinkler system, which essentially controls the fire and protects the structural integrity of the building.
Now, the sprinkler system, it goes into one specific area or it goes into all the areas?
It's a very good question. It depends on the jurisdiction. Specifically, if we're talking U.S. areas, there are certain states or even cities, municipalities where the authorities having jurisdiction, which could be a local fire marshal, or like in New York City, it would be the New York City Fire Department, you know, similar agencies. Those agencies usually require sprinkler systems as the last backup. They will not allow you to completely eliminate sprinkler systems. So even if you have gas use, as a last resort, you still have to have sprinkler systems within the same area.
Mm-hmm. So it doesn't happen like in the movies that one sprinkler goes in and then immediately spreads around?
No, you have to understand that, you know, the sprinkler system is a mechanical system. You know, it's a network of piping, and at certain distances, there are sprinkler heads that are hard connected to the piping. For example, if you have a pre-action sprinkler system, the piping is usually filled either with compressed air, or the latest trends for the last probably 10, 15 years would be a nitrogen system that fills the piping. So if we're talking in many cases a double interlock pre-action system, the piping network is filled with gas. And in order for the water to start spraying, you need two things as a minimum to happen. You need a detection, which means there is a smoke present, and you need rise of heat, which will melt the fusible link of a sprinkler head. So when that happens, the two of these things have to happen simultaneously, then the fire alarm system will trigger a valve that holds the water, okay? The valve will open and the piping of a sprinkler system will be filled with water. However, only if it's only one sprinkler that is open, you'll see water discharging from that one sprinkler head. All the other sprinkler heads still are closed, so there will be no water discharge.
Wow, okay. Now, how they manage the budget to have the right design for fire protection and life safety? I understand, I mean, when it comes to the budget, I've been in meetings where we focus on electrical, mechanical, this $1 million equipment, but when it comes to fire protection, how they select, okay, let's give some priority to fire protection and life safety?
Life safety and sprinkler systems and fire alarm is something that is dictated by code. It's not something that anybody desires, but it's a necessary thing to do. So you cannot get away with not doing it. So there are some owners that would like to protect their assets, even if it's a co-location. They wanted, you know, a better protected building, which they can, you know, advertise for the clients, because they have very sophisticated systems that will protect the client's assets. So there will be no accidental water spillage. There will be a very early notification if something goes wrong in the system. So when we look as engineers, when we look at, you know, different data centers in different occupancies type, like, you know, financial institutions, co-locations, government, we also look at the complete envelope of the building, what would work for the building, how open the areas or how sealed the areas one from the other. There is many aspects of the building that also plays a role. So when we look at everything and we know what's the end game for the client, we come up with a recommendation. So it's the way EYP works. We don't do cookie cutters. We look at each individual client. We get familiar with what they want to see at the end, what is their desire in types of protection, what is their budget. We have to be very, conscious as to the budget of the clients as well and watch their expenditures. And we come up with this recommended systems and we build on it. So, like I said, no cookie cutters.
Right.
Every client of ours is unique with unique needs, and we cater to their needs.
Now, you start designing in the very early stages, or you wait for the MEP equipment specification?
In EYP, we are involved in the very early stages. By we, I mean me and people that work with me. Mm-hmm. So when we working on the master plan, depending on the footprint and configuration of the building, we get involved because I know how the systems work, for example, how far I could be with a pre-action valve room from the area that I'm protecting. If we get involved with the clean agent, absolutely I have to know, am I doing a central storage type system for clean agent with one location or multiple locations. So we get involved in the very early planning stages, like when we do the master plan for the client. So depending on what is the client's desire, what is our recommendations, when we coordinate and come up to a common goal, I know what they need. And I get involved very early to tell them I need so much room. It has to be, spread throughout the building, along one wall or whatever. So each configuration is different. Each requirement is different. So it's very, very personalized.
So switching the topic a little bit more focused towards the air aspiration. Now, is the air aspiration detection it's only used in the white space or IT area?
Not necessarily. Again, we go back to money. Money dictates everything, right? So when we deal with a tier 3 or tier 4 data centers, we have air aspiration throughout the facility, because air aspiration also known in the industry, in many cases they call it VESDA, even though VESDA is just a name of one, manufactured detector. It's made by Extralis. So, but it's so widely used that the industry calls it VESDA. So just for everybody's sake, we'll call it VESDA as well. So, like I said, tier 3 or 4, are utilizing VESDA almost throughout, because it gives you such an early warning of what's going on in the environment, that when human beings cannot see the smoke, cannot smell the smoke, the air aspiration detector will detect the smoke, will give a signal to the security personnel, because we know that data centers are mostly 24/7 manned. And they would have a chance to go and take a look what's going on before we get everything else involved, the bells and whistles and sprinkler system and clean agent discharge. Before chows, start, we have a good chance for the people to interfere and do something maybe manually, like use fire extinguishers filled with, gaseous extinguishment, and get, control the whatever combustion is happening, control manually. So air aspiration, yeah.
Go ahead. No, please.
Air aspiration is not a cheap system. Obviously, in my opinion, it's well worth to install it because what you can prevent from happening. And many of our clients, they do like the air aspiration, and we install them as a minimum in the critical areas for sure, like MMRs, like PDU rooms, like data halls themselves, electrical and mechanical infrastructure areas, stuff like that. So we love air aspiration detection system.
Can air aspiration be used to detect COVID in the area?
I wish we would all be multi-billionaires. Unfortunately not. Air aspiration system sucks in air constantly. It's like a little vacuum, and it looks via laser systems, it looks at particles of smoke. Now, particle of smoke has why it sees particle of smokes, because particles of smokes have a certain configuration and size. So for example, if you have something else, aerosol in the air, it won't see the aerosol because the aerosol particles are different from smoke particles. Unfortunately, it cannot see COVID, it cannot see viruses. But it's a good idea. Maybe we should ask Vesda to look into it.
Yes, maybe in the future, who knows? So speaking of the future, what has changed with the technology?
Well, obviously what has changed is we have, addressable, intelligent fire alarm systems. So we can detect any combustion at an extremely early stages. We can pinpoint where the combustion is, almost to like pointing a finger and saying, this is where the combustion, this is where the smoke is coming from, like this is the piece of wire, because what could cause combustion in the data center where you have no storage, you don't have a lot of fuel for a fire. The only fuel for a fire is an electrical combustion process. So it's overheated cables, it's malfunctioning chips or something like that. So the technology brings us to a very addressable location, like pinpointing where the combustion is happening, and we can deal with that, or rather the people, security people, managing people in data centers, they can deal with this in the very early stages and address it manually before the disaster strikes, and you need sprinklers and you need fire department on site. As a matter of fact, it's interesting to pinpoint that most of the fire departments, at least in the US, they don't want the signal from aspiration detectors to be transmitted to them, because they don't want to be called to a data center in the very early stages. Plus, there are, years ago, now it's been more and more eliminated. Years ago, there was a lot of false alarms, because the system is so sensitive that if you don't maintain the system and it's dusty, it doesn't see the dust as a smoke, but it will malfunction because the detector becomes dirty. So the fire department, in most cases, we do not connect the signals from the aspiration detectors to going directly to the fire department. So the only thing that goes to the fire department is usually, if you have a fire pump, then the signal from the fire pump starting, or water flow alarm, or, if it's a gaseous system, then the discharge of the gas and things like that. Because the fire department doesn't want to get involved in the very, very early stages. They cannot dispatch fire department if there are false alarms or there is a small thing going on that could be taken care of locally.
Now, new technology is coming. We're talking about renewable sources of energy. We're talking about alternative sources of energy, for instance, and even storage, battery storage to be more specific, lithium ion, or we're talking about gas turbines. How does that affect the way that it's specifying when it comes to fire protection, or the way that it's preventing in case of preventing, or even in case of a fire, what are the measures that needs to be done? I mean, as you mentioned, energy or electricity, to be more specific, that mixing with water, it's a no-go. So how does that affect when it comes to lithium ion, for instance?
We've been the whole industry, fire protection industry, is still working on Li-ion batteries and its protection. Mm-hmm. The Li-ion batteries, we know it's an excellent storage for energy, and the problem with it that it's very volatile. So if it catches fire, the fire is very fast, very hot, and it will grow exponentially, and you don't have time to manually, for example, act on it. So most jurisdictions allow Li-ion battery storages, large capacity storages, outside of the buildings, not inside. Because in order to protect very valuable data center, you don't put fuel right next to the data center. The only known protection as of today for Li-ion batteries is tons of water to cool it. That's the only known thing. We tried gaseous systems, we tried aerosol systems, we tried many other things, but so far the industry did not come up with with a system that is completely satisfying everybody at the same time, saving lives, saving data centers, and saving the environment. So we're still working on it. There is a lot of research, as you understand, going on in that direction, and I'm trying to stay on top of it. I'm participating in all kind of research meetings and things, but as of now, we have tons of water that need it. That's why water and data centers don't mix, so it's good to put those storages outside of the building.
Now, what affects a bad decision in terms of fire protection?
Bad decisions affect anything in our life. When you make a bad decision, you may pay dearly. Bad decisions in fire protection is not thinking of, number one, protecting life, because there is nothing more valuable than life. So a bad decision making, in protecting life, it's only the fire protection systems. It's not just sprinklers, fire alarm, gaseous systems. It's also architectural features of the building, like the distances to the nearest exit. It's the annunciation systems. It's being able to control panic within the building. So a bad decision would be not putting together a system or a building that does not take into consideration life safety. Sometimes you try to, to save money, which is, we all try to do that. We don't like to spend our clients' money unnecessarily, but sometimes the decisions are made during value engineering, where the contractor comes and suggests to eliminate something or reduce something, and he offers the client, a certain amount of savings, and the client goes for it because he's already over budget. That could affect, because the first thing that you cut, you don't cut, electrical supply, you don't cut mechanical cooling. What do you cut? You cut fire protection or fire alarm, and that would be a really bad decision. Mm-hmm. So, but we always work with the client. We have a great trust. They understand we're watching for them. We're watching every dollar that they have to spend, and we will not recommend something that is a luxury, that is not a necessity. Right. Okay. So like I said, no cookie cutters. Each client unique, each data center is specific. And each client is the most important entity for us.
Now, the last question, Bella, and I think it's been great having you in this podcast. Any recommendations that you have when it comes to the client's budget? I know that we're talking about no cookie cutter, but how do they begin? Where is the starting point to have them find the right budget or the right design, or any other recommendations that you may have to the clients?
Early involvement of fire protection and fire alarm engineers in the process. Unfortunately, it doesn't happen often. EYP is very different. I get involved at the beginning of every project, and I come up with the recommendations, knowing what the end product should look like. So early involvement of the engineers. Another unique thing that is only mostly in EYP is that fire protection and fire alarm is a combined trade. So you have one group of people that do those two different trades, where other companies, unfortunately, the fire alarm is done by the electrical, the fire protection is done by fire protection engineers, and there is not always the same understanding, the same goal. So early involvement, the companies should train their fire protection engineers to have a good understanding of the fire alarm systems and hopefully design both. A lot of people will be hating me for what I'm saying, but it worked for us for many years, and eliminated a lot of errors and omissions during the process. So this is one of the recommendations. Also, the recommendations is for the clients to sit down with the engineers and listen to them, and the engineers to listen to the client. What do they want? And come up to a common denominator that works both for the client and makes the engineer comfortable with the decisions made during the process.
Right. Bella, thank you so much. It's been great having you here. I think, at least from my side, I learned great information and new information from a fire protection and life safety perspective. Thank you again, and I hope I see you soon again.
Thank you for having me and letting me talk with passion about my trade. I loved it. Thank you.
Right. Thank you.
Bye-bye.
Bye.